Dear participators, my name is Philipp Schwab. Welcome to our CAD-PLAN webinar stream. What you always wanted to know about ATHENA assembly groups. Today I would like to create a footer assembly group with you in simple steps. For this we have worked out a template. I opened this with our PDM system Kronos. Here in our model space you see a top and a side view of our footer assembly group. With simple ATHENA 2D functions you can create a technical drawing of your assemblies. Here we see a simple 3D model and on the left side an example with our finished footer assembly group. So a footer for the mullion with all processings, with the standard parts, with the steel plate, and of course a special notching for the membrane later. Let's take again a small overview to our technical drawings with the special labeling, the notching, all the details and the dimensions we need to create a bus assembly. So now let's get into the ATHENA assembly editor. So I changed the size of the dialog box, and options for a new assembly, opening, saving are in a familiar design. Also the library structure. So let's import the first component. So directly from the model space. So the steel plate, the slotted holes, and also the holes for the mullion insertion profile. So I pick these 4 objects and the base point. So that's very important later to arrange the bar assembly to the profile. So now we imported the different objects directly into the assembly editor and we change the level of the different objects. So I'm very happy to show you later some different possibilities to manage the different levels of the different objects. So we save the first component, give them a name, and for example an item number and a designation, mullion footer plate. Okay? And now we have this component saved in our folder. Here you can change the visual style and the view, and you can see we have here our first 3D assembly group. Now we leave the first component and we pick the insertion profile as the second component and also the holes for the mullion processing. So here also we change the view here to this isometry and we give them a label name, mullion insertion. Then an item number, so it's a special Schüco item number, so because it's a Schüco profile. Okay. So now we have to give the contour a length. No, not on this, not the position. So here the length, not -5, so 100 millimeter. Because in the model space it's only 2 polylines. So and we have to extrude them to our 100 millimeter length. So we change the position of the holes and we also save this second component of our assembly group. So it's MF01.2, the right designation, mullion insertion and also item number. Okay. And also in our English assembly group folder. Now we're leaving also the second component and we create a compound part from our folder. So you can add different assemblies from your database and create compound parts. So we can illustrate this like blocks in AutoCAD. So blocks in blocks. You can add assemblies, you can change the assemblies and create other new assembly groups. So, but of course, they are Athena 3D objects, and it is very powerful and very intelligent. So we add here the screws for the mullion insertion, also with our base point. The base point is our reference point. We change the view, and now we can see the screws are on the right level. It's perfect. So now we add the screw joints. So from our model space. Add. And then, yes, we add these objects with our special holes for the mullion. Of course, you can add more objects at once, but I will show you this in a step-by-step how to create a bar assembly. I think this helps you to understand how this Athena function works. So we do it in small steps. We also change the view, and now we change the position of all the new objects. So the drilled holes and the screw joints. So here I insert 64 millimeters. So we have the dimensions also in the model space in our technical drawing. But I can show you later, we have different possibilities to change the position. So now we change the designation and the item. And of course you can add also special screw joints to your Athena favorite library. So you can add this quickly in your model space, or for example here in the assembly editor. That's a big benefit to create your own screw joints, especially for your projects or different kind of constructions. So now we add a new part, so also a screw joint, so Hilti anchor, and we insert it manually in the assembly editor. I copy the anchor 4 times, and then I will show you how to change the position in a temporary model space. So that is a intuitive kind to change the position or insert parts in your assembly group. By the way, a big benefit for you if you need joining elements in your 2D technical drawings or in your 3D drawings, or here in the assembly editor, you can take this also from our standard part library. We have almost 100,000 different standard parts, joining elements and special profiles. And if you need anchors or different screws or profiles or semi-finished products you need in your special construction. And of course, if you show our next webinar streams, I show you more powerful Athena functions again and again. Okay, so we're finishing out the positioning of the anchors, and we change our view again. And now we have our complete bar assembly. And of course we save this also in our English folder, and the name is MF01, and the designation is footer, plate or bracket complete. So it's the complete assembly group. And the item number is also MF01. Okay. So, okay, well done. So we want to go back to our model space. So I have forgot something. So our notching for the mullion. So I insert some auxiliary lines. So on the edges of the contour and here on the base point. So now we do an extrusion with a special ATHENA extrusion command. So we can use then, yes, this extrusion for a processing or a notching in this case. So we give the object a name, mullion notch, okay. And now we have to rotate this extrusion to the right position. In this case, we move the object to the world coordinate system in the z-axis. Okay, and then we move it to our right position so that we move it to the base point, to the mullion profile. Okay. So we open the assembly editor again. So we have here our complete footer assembly group, and then we add or pick our ATHENA extrusion. And then also the base point is the reference point of our assembly group. Okay, then we have here our processing or the notch for the mullion, and we change the position to 86.5 millimeters. So we have also the dimension of the position in our technical drawing of our object. Now we can save the assembly. But first we have to change the operation. So it's a difference operation. So because it's a notching. So only the ATHENA drilled holes are automatically in the operation of difference. So it could be that you have a difference, or it's also a part with a material. Okay, so now we can arrange our assembly group to the mullion. We use apply arrangement. Then we add a new assembly group. Here we have the arrangement manager. And then we take our new complete footer assembly group. Okay, and it's on the start of the mullion profile. So we have here different options, but we use only here the start, and ATHENA generate the assembly group here to the profile. And we see the notch, the screw joints, the standard parts, the anchors, and the footer plate, and the different components of our bar assembly group. So we can see here our result. Okay, it's in a complete view. So we have the possibility to use different display modes. So it's the detail. So it's the detail view high or it's low. So it's not necessary to show all the details of the bar assembly all the time. But here we see the result, also the holes, the processing for the mullion. Yes, also the special holes on the bottom of the plate. Yes, and I think it's a very high detail assembly group. But for example, you want to export this model as an IFC file. It's also possible to select a lower detail level. So it's better for the export. So the informations are the important things in a IFC file. So now we do a number of article lists. So we evaluate our assembly group, and now we see the result. So here we have a part list of all our different components, the standard parts, the screw joint, and yes, we have only 2 assembly groups, but if you construct a big facade, you have many assembly groups, different assembly groups with different and many different components, and it's a big benefit to create such part lists. So in the next step, we create a bar diagram with the mullion and the assembly group. So and here you can see, yes, for your work preparations, you can also generate bar diagrams, including the assembly groups and the processings. So, and of course we have much more functions. For example, here the export, BIM, XML, SAT, EluCAD export, and so much more to evaluate your 3D construction here in Athena. And of course we have so much more powerful 3D functions, 2D functions, 2D plus functions, and I'm very happy to show you this in our next webinar streams here on our channels. And yes, so now we close our stream. Thank you for watching, and we see us in the next time. And of course you can write me, for example, on my LinkedIn profile. So bye bye and have a nice day.